Hey everybody, we're going to be doing some work with fractions. So our first page in our little fraction book says determine if the fraction pairs are equivalent. And remember, this word equivalent just means equal. Are these fractions the same? They look a little bit different, they might be wearing a different hat, but are they equal? Explain your answer. And so we're going to be explaining it using numbers. This is math class. So I have 2/8 and 1/4. So 2/8, I'm going to divide my 2 and my 8 both by 2, and that's going to be, I'm going to bring this over here. 2 divided by 2 gives me 1. 8 divided by 2 gives me 4. So 1 and 1, 4 and 4. Yes, these are equivalent fractions. 6/8 and 3/4. So I'm going to do something over here to this one and see if I can make it look like this. So to turn a 4 into an 8, what would I do? I would multiply it by 2. What I do to my denominator, I also do to my numerator. Multiply it by 2. 3 times 2 gives me 6. 4 times 2 gives me 8. Well, 6/8 and 6/8, yes, so those are equivalent. And remember, whatever you're doing to our denominator, you have to also do to the numerator. And it doesn't matter which fraction you're doing things to. Remember the first one, I did something to the first fraction. The second one, I just wanted more room to be able to work with, so I did it to the second one. Over here, I could work with the first fraction or the second one. It doesn't really matter. So let's say this problem number 3, I'm going to rewrite it 3/9 and 2/3. So I'm going to work with this one. What do I want to do to 9 to see if it could turn into a 3? Well, I would divide it by 3. So what I do to the denominator, I have to do to the numerator too. So 3 divided by 3 gives me a 1. 9 divided by 3 gives me a 3. So is 1/3 the same thing as 2/3? No. So these are not equivalent fractions. So we just go like this. No, they're not equal. They're not equivalent. 8/10 and 4/5. I kind of liked rewriting them. It gave me more room. 8/10 and 4/5. Well, same thing. What would I do to 10 to turn it into a 5, or vice versa? What would I do to 5 to turn it into 10? Well, over here I would divide it by 2. That would turn it into a 5. So what you do to the denominator, you have to do to the numerator. You've got to divide by 2. 8 divided by 2 gives me 4. So 4/5 is the same thing as 4/5. So yes, these fractions are equivalent. Now problem number 5, I have 2/3 and 10/15. So what would I do to 3 to turn it into 15? Well, I'd multiply by 5. So what I do to the denominator, I do to the numerator. 2 times 5 gives me 10. 3 times 5 gives me 15. So are these equivalent? 10 over 15, 10 over 15? Yes. So now over here we're going to simplify these fractions. So we're going to be looking for a number that goes into both the numerator and the denominator. And remember, when you're simplifying fractions, you know you're in simplest form when the only number that can go into both the numerator and the denominator is 1. All right, so I can divide both my numerator and my denominator here by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So I can't divide 1 and 4 by anything other than 1. So I know I'm in the simplest form. 6 and 8, I can divide both of those by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. And this is in the simplest form. Nothing can go into both 3 and 4 except for 1. 3/9, I can divide both 3 and 9 by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. 8 and 10, I'm going to divide both of those by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. 4/6, we're dividing both of those by 2. 2 divided by 2 is 2. 6 divided by 2 is 3. And I want to just pause here for a second and let you notice that as we're simplifying the fractions, the numbers should be getting smaller, because when you divide, your numbers get smaller. 6/9, we're dividing by 3, because 3 goes into both 6 and 9. 6 divided by 3 is, 2. 9 divided by 3 is 3. Got ahead of myself there. 9/12, I'm going to divide by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. 8/12. Ooh, I can get a little bit bigger here. Okay, so I can do a couple things here, and I'll show you what I can do. I can just go for the big guns, and I can say the biggest number that can go into both 8 and 12 is 4. 8 divided by 4 is 2. 12 divided by 4 is 3. And that's my final answer. Or if I didn't know that right off the bat, I can show you what else I could do. I could start out with 2, because I see that both of these are even numbers, and I could go 8 divided by 2 is 4. 12 divided by 2 is 6. But then I'm not finished, because I see that both of these can be divided by 2 again. So then you just go one more, and then you get your final answer. But I can see that this, when you divide it by 2 and 2, if you multiply those together, what do you get? A 4. That's just a fancy trick for you. All right, 10 and 14, both of those can be divided by 2. 10 divided by 2 is 5. 14 divided by 2 is 7. 6/15. Well, what goes into both 6 and 15? If I listed out my factors of 6, which is what we're doing here, we're pulling out a factor, I would have 1, 2, 3, and 6. My factors of 15, that means the numbers that you multiply together to get 15, are 1, 3, 5, and 15. This is how you find the common number that you're going to divide by is 3. So you're going to divide by 3. So when you get stuck, this is always a great idea. 6 divided by 3 is 2. 15 divided by 3 is 5. 10/15, I'm going to divide by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. Whoa. Was kind of losing my mind there for a second. 2 divided by, or 2 over 14, I'm going to divide by 2. We get 1. 14 divided by 2 is 7.